Alright, here we go. 1.5. Describe angle pair relationships. Okay, a couple of vocab terms to start. Complementary angles. Complementary angles are angles that add up to 90 degrees. Just a reminder, this little symbol means angles. So if you have an angle that is 60 degrees and another angle that is 30 degrees, if you add these two together, you get 90. So these two angles would be complementary. Supplementary angles are angles angles that add up to 180 degrees. So, for example, if you have an angle that is, I don't know, we'll use 60 degrees again, and then an angle that is 120 degrees, these two numbers add up to 180, so these two angles would be supplementary. Adjacent angles are angles that share a side. Okay? They look kind of like this. This angle and this angle are adjacent because they're attached here. They share this side. Two angles that share a common vertex or side but have no common interior points. Alright, a linear pair. A linear pair is a pair of angles that are adjacent and supplementary. Basically, they make a straight line. They add up to 180, but they're also attached, like this. Okay? It's also interesting to note that the sides that are not adjacent, so this side of this angle and this side of this angle, they're opposite rays. If you have that, if you have opposite rays like that, you know you have a linear pair. Okay? Alright, vertical angles. These are two angles that look like this. They form kind of an X. This angle and this angle are vertical angles, and this angle and this angle are vertical angles. Notice that I used arcs to show this. That's because vertical angles are always going to be congruent. These two angles are congruent, and these two angles are congruent. Also interesting to note, these two sides make opposite rays, and these two sides make opposite rays. Alright, example 1. In the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. Alright, remember, complementary means it adds up to 90 degrees. 52 and 38 add up to 90 degrees. Okay? Therefore, ABD, that's the 52 degree angle, and CDB, that's the 38 degree angle, are complementary angles. Okay? Likewise, let's see here. 52 plus 128 adds up to 180. Okay? Therefore, ABD and EDB are supplementary angles. Okay, now let's take a look here. Adjacent angles, angle CDB, that's this angle here, and angle BDE, they share this side here, and they don't share any common interior points. That makes them adjacent angles. Oop. Make sure the D is in the middle because D is the vertex. Okay, on a side note, angle BDE, that's this angle here, and angle CDE, that's this angle, they share a side, but they also share common interior points. So this angle and the big angle cannot be adjacent because they share common interior points over here. Okay? Alright, let's take a look at page 2. Example 2. Given that angle 1 is a complement of angle 2 and the measure of angle 2 is 57 degrees, find the measure of angle 1. Alright, the measure of angle 1, we know that these are complements of each other. They're complementary angles. That means this angle and the unknown angle have to add up to 90 degrees. So the measure of angle 1 is going to be, let's see here, 90 degrees minus the measure of angle 2. And we know the measure of angle 2 is 57. 90 minus 52, or sorry, 57 is 33. So this one has to be 33 degrees. Alright, part B. Given that angle 3 is a supplement of angle 4, and angle 4 is 41 degrees, find the measure of angle 3. Alright, so the measure of angle 3, they're supplementary. That means they add up to 180. So 180 minus the measure of angle 4, and we know the measure of angle 4 is 41 degrees. That means the other angle has to be 139. Okay? Put my little degree symbols here. Okay, checkpoint. Go ahead and pause the video here and try these 3. And then when you're ready, go ahead and move on. Page 3. Example 3. Find angle measures. Okay. So the basketball pole forms a pair of supplementary angles with the ground. This one and this one. We're going to use the fact that 180 is the sum of the measures of the supplementary angles. Because we know these are a linear pair, they're supplementary, when we add these two angles together, we're going to get 180 degrees. Now we're given equations for each of these. BCA is 3x plus 8, and DCA is 4x minus 3. And once again, this all adds up to 180. I'm going to combine like terms. 3x plus 4x is 7x. 8 minus 3 is 5. And this adds up to 180. Let's subtract 5 from both sides. So now I've got 7x equals 175. Okay? And now I'm going to divide by 7. So x is going to be, let's see here, 25. Okay? So we have x, but that's not what they're asking for. They're asking for these two angles. Okay? Oh, by the way, BCD, hopefully you guys realize that this is a straight angle. So, once again, we have x. Now we just need to plug it in. We know that BCA is 3x plus 8. So I'm going to plug in 25 for x. So 3 times 25 plus 8. 3 times 25 is 75 plus 8. That would be 83. DCA is 4x minus 3. So I'm going to plug in 25 again. 4 times 25 minus 3. 4 times 25 is 100 minus 3 is 97. So the angle measures are 83 degrees and 97 degrees. And if you add these two together in your head, you get 180, which is what we're supposed to get. Alright, go ahead and pause the video, try this checkpoint, and then move on to page 4. Example 4. Identify all of the linear pairs and all of the vertical angles. Okay, so to find vertical angles, we're looking for lines, for angles formed by intersecting lines. Okay, so for example, angle 1 and angle 3 are formed by the same intersecting lines. So these are vertical angles. To find linear pairs, we're going to look for adjacent angles whose non-common sides are opposite rays. Okay, we're basically looking for angles that make a straight line. Angle 1 and 2, these two angles make a straight line. Okay. Also, angles 2 and 3, these two angles make a straight line. Okay. Now, in the diagram, one side of angle 1 and one side of angle 4 are opposite rays, but the angles are not a linear pair because they are not adjacent. Remember, adjacent means attached, and the angles have to be adjacent in order to be a linear pair. Alright, you can pause the video here and try this one. Example 5. Two angles form a linear pair. The measure of one angle is 4 times the measure of the other. Find the measure of each angle. Okay, so we have one angle here, and this angle is 4 times whatever this angle is. So if this angle is x, this angle has to be 4 times x. Okay? So let x be the measure of one angle. The measure of the other angle is, once again, 4x. Then use the fact that the angles of a linear pair are supplementary. Remember, supplementary means they add up to 180 degrees. So x plus 4x have to add up to 180. X plus 4x is 5x. I'm going to divide each side by 5. These cancel out. So x equals, let's see here, that would be 36. Okay. The measures of the angles are 36 and 4 times 36, which is 144. Another way you could have done it is just to subtract 180 minus 36. You get 144. Alright, last page. We have a checkpoint. You guys can go ahead and pause and do that on your own. Okay, concept summary. Interpreting a diagram. There are some things you can conclude from a diagram and some you can't. Okay, for example, here are some things that you can conclude from the diagram at the right. All points shown are coplanar. Remember, coplanar means they're all in the same plane. This isn't a three-dimensional diagram, so all of these points are in the same plane. Points A, B, and C, they make a straight line, so they're collinear. And B is between them, between A and C. Alright, lines AC, BD, and BE, I guess these two are rays and this one's a line, intersect at point B. Remember, intersect means they all cross. So all three of these figures, the line and the two rays, intersect at point B. Okay. Angle DBE and angle EBC, these two, are adjacent angles. Remember, adjacent means attached. They share a side. And angle ABC, that's this angle here, is a straight angle. Point E lies in the interior of angle DBC. In the diagram above, you cannot conclude that AB is congruent to BC, that these angles are congruent, or that ABD is a right angle. This is what you would need to see if that was the case. You would need to see these little dashes, which means they're congruent, these arcs, and this little box.